recording. Cool. Go ahead and converge this topology so we can see how traffic will travel throughout this network. Zamir, can you tell me which switch is the root bridge within this topology?
Yes, I'm here. I'm still looking at it. 1 second.
Take your time.
And this is only for Zamir, right?
Yep. You guys can help him.
I'm going with switch 1, perhaps, but I'm looking really good. No, excuse me, maybe switch 10.
I don't know if I can tell by looking.
Yeah, I'm thinking switch 10.
Okay. What's your reason behind it?
They all start off the same, but that looks like the lowest value. Maybe.
And guys, feel free to help each other out. So.
All right. Aren't root bridges usually centralized?
Not necessarily.
There's MAC addresses up there.
What do you mean by centralized? Somebody was just talking, you muted yourself.
I think what the notion was, the centralization of the root bridge. So I think what's throwing a loop is a root bridge showing up on possibly an edge of the
This is
topology.
all a layer 2 topology.
Yeah.
All layer 2 guys.
Got you.
No, there's no router in sight. Again, where we're at right now, we're trying to identify the root bridge.
Is it not? Was it not switch 10?
Is it switch 1?
Remember, it's hex. Oh boy, remember how hex? If y'all know how hexadecimals are, that'll give you kind of like a clue on which one is the root bridge.
Keep going, Twan.
Because I remember hexadecimals from doing binary math and hex and hex starts at
after 9.
After 9. So if 10, so 11 would be A. So if that's the case, then switch 1 is your root bridge.
Can everybody agree? Is that your final answer?
I agree that switch 1 is the root bridge, but only because it's 50010001. And the other switches have a higher value in that place.
Okay. Which means this would be the switch with the lowest bridge ID, correct?
With the lowest MAC address, probably would be the bridge ID if all the priorities are the same.
No. So bridge ID, it compiles of both the priority and the MAC address. So whenever we say bridge ID, it's one or the other.
Yeah. You're right. I'm confused. I'm working at the same time, so I'm trying to do like 3 things.
It's all good. It's all good. It's all good. It's all good. So Antoine, you'll be the Samir, you'll be the spokesperson. So what are we agreeing on, which is going to be the root bridge?
We're gonna agree on switch 1.
Okay. The root. Well, you know what? Let's do this. Perfect. Okay, we got our root. Okay, so let's start at switch 10 and switch 5. So which one is our designated switch between switch 1, switch 10, and switch 5?
Switch 1. Hold on. God damn.
Repeat the question. I
Is
did
it
that back.
maybe switch? Will it? Oh, never mind. Maybe I'm thinking about a different point. Never mind.
and think about it. Just look at it for a little bit.
No, I was
Okay.
thinking switch 5 because it's closer to the
Hold
root
on.
port,
Okay.
to the
You
root
said-
bridge.
Hold on. So you're saying between switch 10 and switch 5, which one is the
The
designated
designated switch.
the designated switch?
I would say switch 10 because it's 100 megabits.
Okay, tell me, what does that mean?
The cost is what's that? All depends. It's the cost of the link of the link.
Wouldn't you go to the cost if it was like, I think the cost is one of the tiebreakers, right? Excuse me. Hold on.
Well, the cost is how fast it's going to get is going to traverse the link.
But they both have 10, 100, and 1,000 megabits.
Paul, do you want to help him out?
Okay, where they stuck at?
What's up?
So choosing the designated switch between
All right,
switch
what's going
10,
on?
switch 5, and switch 1.
All right.
So think about it like this. Think about it like this. And this is something that you may not see in the textbooks. But if you were to take some scissors and cut the root out, which one of those switches would be next in line
Well,
to take over?
yeah. What? Fill me in. What happened?
5.
5 would, right?
Well,
Because
no, David. I mean, David. Like
switch
relate
10,
message. What happened?
switch 10, you
What's
can
going on?
see that MAC address is OA. So that that's how that has a higher MAC address.
Understood.
So switch 5 it is.
Why?
Because it's informed us that the MAC address is lower than switch 10, which I didn't know that either, that the A meant a higher value than the number. So I learned something.
Oh, I thought we were looking for the. Are we not looking for the root
I'm an
port?
introvert too, man. It's just I'm telling you, I be
No.
shooting off the hip, man. This is
Is that what
I
is
should-
that, is that
no,
what
no.
y'all looking for? The root port?
because you
No,
are
no,
bringing
the
out of me.
designated port.
Like with Blas. See, y'all think I be joking when I say that Blas brings that out of me. All the arguing and debating, yes. I'm so chill and laid back, bro.
Okay.
Are you talking to us or?
No, I think he's on the phone. Okay,
Okay.
so we know that the
No,
root.
so we're
We know. Oh, I'm
we're
sorry. Go
looking for
ahead.
the designated switch. My bad, Claude. Yeah. So we're trying to identify the designated switch.
All right. So if we're looking for the designated switch, then we're going to go with switch 5, which has the lower bid.
Okay. choosing the designated switch, what are we looking for? Feel free to Google, guys. It's perfectly fine to Google and to look in your books, do what have you. We're studying. We're trying to get right. So you guys don't have to remember this from the top of your head.
I think somebody touched on it earlier.
It has to be connected to everything. Everywhere.
Take a look at your so we know the root is number one. Take a look at your speeds coming out of number one. I think that's gig 01. I know that's tiny, and gig 00. Take a look at those speeds right there.
Also, I've seen too that it said the one the switch with the lowest cost to reach the root becomes the designated switch on that link.
You're getting there. Samir, you're getting there. You're getting there. You're getting there. So close. So the designated switch is a switch that shares a link between two non-root bridges, so switch 10 and switch 5, between each other. Who, just like you said, Zamir, whoever has the lowest cost to get to the root from these interfaces will win the election of the designated switch.
Okay. Let's see that.
With that being said, go ahead and do the math.
So it has to be connected to the root bridge and each other.
So guys, let's break this down, okay? So whenever a switch is elected as the root, correct? What state are those ports in once it's elected as the root? Is it in a blocking state or is it in a forwarding state?
Forwarding state.
Okay. All right. So if it's in a forwarding state, what's the other name for that? We have the state, but what's the role of the port? What is it called?
Root port.
Designated port, correct?
Yes.
Wait.
Cool.
It's the designated.
Go ahead and do that. Designated.
Oh, so that's not the root port?
Look back on your text. So with spanning,
the root port is the ports that's gonna be on the other switches, but closest to the root bridge. I mean, the ports that are closest to the root bridge, right?
Exactly. So it's the ports that it's the ports that connect. That's been elected. That's the fastest way to the root.
Oh, okay.
And this is only on a non-root bridge. Okay. So with that being said, let's go ahead and convert. Let's take it slow. Let's go ahead and convert who would be in a forwarding state on the ports on switch 10 and switch 5. Who has the lowest cost to reach the root? Which links?
Lowest cost. Oh, shush.
For to reach so you want to know which interface, like if we were talking about switch 5, then I'm making it bigger. It would be like, what's that interface 1/0 G1?
Mm-hmm.
Yeah, so that would be the lowest cost. Well, I'm not looking on that side, so I was looking at
Gotta be
yeah.
It gotta be what you call it, link 1 gigabit 1/2 going toward, hold on. Yeah. Gigabit 1/2. What the gigabit 1/2 going going toward switch 10.
Why?
Because the link, because it has 100 megabit, the link is 100 megabits, which is a lower cost than the link gigabit 1/0 going toward switch 5, which is 10 megabits.
Okay. So what's the cost difference? What's the actual numbers?
It is it's 90, well, it's 90 less. Does that make sense?
So you want the cost of like the wires you saying?
Yeah. So I want to know the why, right? Why are you guys choosing the link a gigabit 1/2 on switch 10 as far as that's going to be the root port for switch 10? Why are you guys choosing that?
Okay, one moment. Let me
the bandwidth cost.
Right.
Build on what Twan just said. Build on what Twan was just talking about.
No, I just posted a link in the Slack, so that should give you guys a hint.
I'm just listening, but looking for, the 2, 4, 19, and 100 explanation as far as the bandwidth.
Mm-hmm.
I want to chime in so wide, but I'm just
what I was looking
Oh, okay.
Wouldn't it?
I know we're doing. I didn't know it was a little. Okay, so
yeah, go ahead. I'm sorry. I had it pulled up.
10 is yeah, because they explained it weird in this other video.
10 should be 100 for the cost. If the
And
100 megabits is 19, then
that's
10
right.
is 100. Hold on, I can send y'all this.
I would ask, is it the default bandwidth or has it been modified?
Yeah, the speeds of the links are marked on the link.
Right. So from what I'm looking here, the port cost, the speed.
Well, I was asking that because you know how you change the bandwidth and then so the numbers change, right?
Mm-hmm. Yeah, no configuration has happened. This is all just a diagram. So yeah, these are just straight up links. Get out of the CLI. Don't worry about that.
So let me see here. So 100 is 19.
I guess like Twan was saying, then the one with the lowest number is gonna be the less cost.
Okay, cool. So let's finish it. So what's gonna be the root port for switch 10?
For switch 10, what's gonna be the root port? But that's already designated. So is it GI1 and 1?
Oh shoot. You said the root port.
So
or you saying going between 10 and 5?
I think it's gonna be GI 1/2.
10, 5, and then 1. This is what we're working on. Switch 1, switch 10, and switch 5.
Oh, and that's already designated there. So switch 1. So yeah, I'm gonna have to go with the switch, maybe the GI1 and 1 interface. Well, wait. Oh, that goes to a whole different bridge, so we're not even including it. I see what you're saying.
You said GI, the gigabit?
Yeah, I'm confused as like, does it need to still go to those? Is it just those 3 links that do this port still goes? It's a root port, so it still goes to other switches, right?
Nope. So just like I said, we're just going between switch 1, switch 5, and switch 3. And switch 10.
Okay.
That's it. Just these 3 switches. Don't worry about nothing else.
Will it be G1/2?
Okay. Why?
Because it's on the other side of the designated port, and it has a cost of 19 compared to.
That's what I was. Perfect. Perfect. That's what I was looking for. That's it.
So which one was it?
For it was on switch 10, it was gigabit 1/2 because it had a cost of 19. Versus if we've taken the other link that has a cost towards switch 5 of 10 megabits, which translates to 100, a cost of 100, and then going towards switch 1, another link would be 200 that has a higher cost.
Okay, so even though, okay, I just want to make sure then, because the GI1/2, we already had, oh wait, never mind. I was looking at two different numbers. I was gonna say we already said that was the designated port because it looks like the same line, but now it is numbered different up there. Okay, I see it now. Now I understand the interfaces by each. I was already thinking it was already taken, but that's a whole different interface on two different ports. Now I see it different.
All good.
The designated one.
All good. Cool. All right. Dennis, so let's keep rolling. So what's the root port for switch 5? Why?
Okay, just a minute.
You guys are doing good, man. Y'all are doing good.
Will it be G1/0?
Why?
It's the only connection to the root bridge.
Yeah, it's the only connection to the root bridge. The other side is the designated port.
That's
The
not
cost
a good
is
reason.
the cost
Not a
is
good
100.
reason.
The cost is 100. But if you look at all the other ports, if you look at G0/1, which is 1,000, the cost is going to be 4, and then we're going to have to go to switch 4, and then we're going to have to go to switch 10, which has a cost of 10, and then go back to switch 1, which will be 4 plus 100. Will be 104.
Perfect. So guys, just because it's directly connected doesn't mean it's the fastest way to the root. Remember, it's the root port is selected because of cost. Okay.
Oh yeah, I see. It's only 10 megabits. Got it.
So it's only So it's only 100 compared to.
So I can go around the world and back and be faster than that.
Exactly. Okay. So Dennis, which one are you choosing? You're choosing on switch 5. You're choosing gigabit 1/0.
Yes.
Cool. All right. That's a good enough reason for me. All right. Let's go ahead and put that there. Organize this a little bit. Too much. Cool. All right. Perfect. Now, as far as the links between switch 10 and switch 5, which link is going to be blocking and which one is going to be forwarding? And this is going to complete our selection of who's going to be the designated switch.
You said which one's going to be which one we're blocking?
Between switch 10 and switch 5.
Switch
Is it
10 and switch 5. Hold on. Sheesh, 1,000, 100,000. Oh, hold on. Damn.
I feel like I might.
My head hurts.
I want to chime in so bad, but I can't even focus. But I'm listening.
It's all
hard,
good.
yo.
It's all good. It's all
Hold
good.
on. Damn. Yeah, it's a whole bunch of numbers, man. 100 GB and then 10. Yeah, switch 5, which is 100. Again. Again. And 100.
Hold me down, y'all. Hold me down, y'all. I'm listening hard.
Hold on.
I'm coming. I'm almost there. Hold on.
I'm almost there too. 4, 2, hundo. And
Leading to the bridge.
Just drop the article in Slack just in case y'all need some help.
Damn, messed up.
Y'all
Hold
can
on.
look in that article.
2, hundo. 120. So hundo. Damn, I'm messing up. Okay, hundo. It's 4. I'm bugging out. 4, 8, 27, 19, 4, 19, 38, 42. 38, 42.
So it's the lowest. It's similar to the
Switch
other
10.
These are the lowest.
So damn. And then you gotta block all it.
I was reading up on it that it's similar to the root that is the lowest cost to the root bridge. I guess again the one that will block.
Okay.
So it should be I'll cut you off. It should be.
Go ahead. It should be what?
Damn, I just had it.
Should be switch 10.
Yep. We blocking on switch 10.
Why?
Because compared to the links that is connected to switch 5, switch 10 has a higher cost, which is 127 altogether. Well, actually is
Switch 5 has a higher cost.
But we're selecting the port too, right? I mean,
switch 5.
Yep.
Switch 5 altogether. I calculated it. It's 100. It's 100 gig 100. So it has a lower cost. I mean, I did the math wrong.
Okay. So what's you guys' final answer?
What port is going to be blocked?
I think we're going to block on switch 5.
Okay. Why on switch 5? Give me the breakdown as to why you guys selected that between costs.
Switch 10 has a lower cost getting to the root. It has a cost of 19.
Okay.
And switch 5 has a cost of 100.
Okay.
So I think we'll be blocking on switch 5. That's just my thought.
Okay. So are we not considering the ports between the speeds between switch 10 and switch 5?
I was
even if we
I was thinking initially, but we started saying blocking the switches. I thought that we would have to block to prevent a loop, you would have to block a port, but it's on 2 different ones. It would just have to be the link between them, right?
Yep. Zamir, you're exactly right. So
I wasn't sure which one I was originally thinking, maybe with the lowest cost. I don't know. I can't see behind it, but I would see the 2-1, the G 2-1, I can't see what the other one is, but I'm thinking that's the one that may have the block on it, be the block one, while the other one is the forward.
I'm yeah, I just want wait.
Oh shit. Hold on. Damn it. Okay. That just fucked up everything. Hold on.
Hit your undo and put that piece back. See if that worked. Very top of your taskbar. Very top of your taskbar. It's the undo button up there. Little circle. Keep going up. Keep going up. Keep going up. Right there. That's your undo, isn't it? Or reload.
That's my reload. Yeah, that's my reload.
Oh, okay. Okay.
I was trying to figure it out because I felt like one of them had to be blocked, but if it's by lowest cost, then maybe it's not that 2-1, maybe it's the other one, since it's, I guess, closer on that end to the root, would be maybe the block port, the one that went away.
So wait.
It was one of them. It's got to be the block one forward.
I think I did my calculations wrong. So you would add the port
I'm gonna send you a copy of that topology because I was actually mimicking it on my end as well, so you can see what you had. Stand by.
Hey guy, what was the question?
Oh no, I was saying that I think I calculated it wrong. So it would be you calculate the port speed on the link between.
All right, go to Slack. You got it in Slack. It's processing now. The speeds are in gray on the various links. You should be able to see them.
Okay.
Perfect.
Let me know when it comes through.
There we go. I'll give y'all a little bit more space so y'all can see that.
Not yet. Not yet. All right. So you would calculate. You calculate the yes. So all right. So in order to get what would be what port? Pardon me. What interface we would block between switch 10 and switch 5. You will also add the links that from the designated ports to the root ports, which would from switch 1 to switch 10, switch 1 to switch 5. That makes any sense?
Say it one more time. You add.
Oh no, what I wanted to know, well, I'm actually trying to figure it out how to calculate what port we would block between what port we would block between switch 10 and switch 5 to stop the redundant link.
Hold on, Dave. Hold on, Dave. Switch 10 gig 1.3. That should be 1,000. Is that 1.3 or is that 2? No. Okay. Yeah, that one there. That should be it's that next one. It's that next one. 2/0. You got a 1 meg. You got a 1 gig.
That was me.
No. Yeah.
No, that's just.
Yeah, that's it.
No, that's just my feeling when it comes to being there.
So you got 100 meg take that 100 meg off because you got it marked as 10 down there by switch 2, which is what it's supposed to be. Yeah. There you go.
There we go. There we go. Okay.
Yeah.
Cool. Perfect.
Same
Yeah,
thing.
we got all
Same thing on switch 8 up there in the corner. Gig 01. It shouldn't be 10 megs. That should be 1,000.
100. 1,000?
Yeah, 1,000.
There we go.
There you go.
Oh yeah, so it should be switch 10. All right, so you're blocking it off at switch 5.
Switch 4. Switch 4 is 1,000.
10 megs. And switch 4, that should be.
No problem. You're blocking it off at switch 10 because switch 10 has a higher cost.
I think the one we got
switch 5 got the higher cost.
All right, switch 4. That
It's not
switch
gonna-
4 should be 1,000 instead of 100. Yeah, change it to 1,000.
10.
Just add, yeah, there you go.
Cool.
Yeah. 110.
Let's check all the links.
I think that's all of them. Yep.
Yep, that's all of them. Cool. All right, cool. Sorry about the technical difficulties, folks. So,
Oh, good.
now that we
Oh, you're good.
all
Thankfully,
good and running.
everybody's in IT.
All right,
So
so
you gonna keep that a single link between 10 and 5?
yeah, we're gonna keep it simple.
Okay.
So 10.
Perfect. Cool. So which one is blocking between switch 10 and switch 5?
Switch
Higher.
What's
5.
your reasoning behind it?
Switch 5. Switch 5 has the higher cost.
Okay, explain the cost.
Switch 5. All right. So if you add the link between the designated port to the root port going from switch 1 to switch 5, that is 100, 10 megabits. And then you add the link going to switch 10, that's 10. Altogether, that's 200 compared to the link going from switch 1 to switch 10, which is 100. That's 19. And then you add the link coming from switch 10 to switch 5, which is 10, as 119. 200 is higher than 119.
Okay, so which one we're blocking?
We are blocking switch 5.
Confident?
Yes, I'm telling you, not asking you.
Okay. Positive.
Positive.
Claude, you want to help him out? Guys, look at that article I sent you.
So the one is that we blocking is like 2-1.
Yeah, that's what Twan said that we're blocking. Is that correct, Twan? That's what you.
No.
No, I said that
Switch 5.
earlier before the other one disappeared, but I had a different reason.
Ah. Okay. So which one we're doing?
5.
Ah. Okay. All right. Cool. Just making sure.
That's it.
And then we're. So this one is going to be designated. It's going to be forwarding, right? since it won the election.
Yes.
Juan?
Oh, yes. Sorry about that.
All right, now it's all good. Cool. All right. You just converted your first redundant link. How do you guys feel? Let's take a little breather.
Oh, Lord.
A lot.
Oh, Lord.
I feel like I'm gonna be doing this tomorrow.
Good goodness. Whew.
Yeah. You guys did good though. You guys did good.
Thank you.
You guys did good out. Yeah. You guys
I've
did
seen
good.
you work.
The main thing here, what I was trying to show you guys is I want you guys to be able to do this without looking at the CLI and not to rely on the device to do it. Okay. Once you guys can do it on a piece of paper, do something like this, just make up anything. Because as you guys can see, no devices are on. As long as you guys can do it on a piece of paper and effectively converge a topology, you guys know spanning tree. Simple as that. And that's how, myself, I believe Claude said that he used the on-paper strategy to learn spanning tree. As long as you know how to do that, any exam that you take regarding spanning tree, the CCNA, the Network Plus, what have you, you'll pass it just fine. Okay.
Oh, that's good. It definitely works
Any
with some
questions?
practice.
Yeah, it's just practice. It's just practice. And again, feel free to just, you guys can create, you don't have to create something big like this. Keep it real simple, just like Claude told you. Let me bring this over. Keep it real simple. Something like this. Give the link certain speeds, different costs, and just convert it yourself. Simple as that. Simple as that. I added all those switches just to throw y'all off.
It worked a little bit. Look, we like, wait, are we looking at?
I know it did.
1, 5, and 10. You like 1, 5, and 10. I'm like, wait, where is this link going? Okay.
Because Dennis had it, and I'm like, what are you talking about? And then like I calculated the wrong thing. And then we took that little break, like a little pause for a second. I'm like, wait a minute. I got it wrong, but why I got it wrong? Then I looked, I said, oh, that's what we're calculating. Okay. Now it makes more sense.
And part of it was, I think some of you guys wasn't familiar with the election process, which is okay, right? And that's why I went ahead and posted this link, right? And I told you guys these will work together because spanning tree isn't easy. So, review it, take a look at it. Like I said, just get like, a sketchboard or something like that. Just 10 minutes, 30 minutes. Just, if you're just chilling, just write out a simple topology, simple triangle, and do it yourself. Because once you do that, right? Let me share my screen again. Once you do all of that, you can do that just for one. You'll be able to go ahead and converge any other topology, no matter how many switches there are. You'll be able to say, okay, let's do it. Let's go ahead and do it per segment. I'm able to, I went ahead and converted this already. This is fine, right? Okay, so now I could do this. I could just do the same thing over here.
Oh.
Boom, and then boom. Right? And I could do the same thing over here, right? Boom, boom, boom. Fundamentals, guys. As long as you know the election process for both the root bridge, the designated switch, and designated ports, what have you, you'll be good to go. But it's going to take time. Once you know that, whenever you see these big topologies that Claude bring up to you guys, that you see on LinkedIn that looks intimidating, it's really not. As long as you know what you're doing. Once you guys get in the real world or what have you, I give you guys another big topology like this, you'll be able to convert it with ease. Simple as that. Well, good stuff tonight, fellas.
Go look in your Zoom chat.
Hold on, let me just
I
go
was
ahead.
just looking at it, reading
Yeah,
it, and saying block everything up.
there's a couple simple things. Just remember, and if you can, Dave, pull your topology back up for those 3 switches we just did.
CP.
1 second.
All right. So you got switch 1, switch 10, and switch 5. If you look at them little 4 steps, okay, y'all selected the root bridge. Y'all call that number 1, right? Y'all identified the root ports from the other 2 switches, right?
Yes.
Yes, sir.
Okay. So we already know that the designated the root bridge is going to have designated ports. So you mark those off. Then you know you got to mark off some root ports, right? The quickest way to the root bridge, okay? Quickest way to the root bridge. Then you got to do this. You got to turn on a designated port for the other segment. Turn on one, because you can't have both sides being designated. You follow me? And then you block everything else. That's the secret to spanning tree summed up in 3 or 4 steps right there.
Wow.
Simple as that.
Wow.
Hold on.
Yeah, because I want to ask.
Let me go ahead and take a picture of this, boy.
Look, I did all my Snapchat from before this. I'm like, okay.
Hold on, don't you dare turn.
So what would happen? What would happen, like, if you were still, doing the other switches that's connected to it too? Would that wouldn't change what you block, or it's just for if it's 3?
Just for that triangle. We're gonna keep it simple.
Perfect.
Just for that triangle, right? So
Yes.
just like I did, and I'm gonna keep it real simple. I'm not gonna use big ass words because we're not just about to do that. I want you guys in the learning stage. So, right? Let me use a different color. Hold on. Where we at? Let me. Okay, we're gonna use purple. I like purple. That ain't gonna work. Let's use green. Okay. All right. So, like I told you guys, this right here, right? Let's talk about this link, right?
Yep.
Right. It's a redundant link. It's a redundant link between switch 7, switch 5, switch 10. Okay. What does it mean by redundancy, right? If switch 10 fails, it could still send traffic to switch 5 to get to possibly PC1. Okay. But, right, Twan, keep me honest here, because me and you talked about this a lot. One of the 3 primary jobs of a switch is to prevent loops on redundant links using spanning tree.
Yes.
Twan, am I right or am I wrong? Keep me honest.
You're right.
Cool. So look at spanning tree exactly how Claude just said. Slow it down. You know you're gonna have your root bridge. You have that elected, boom, check that off the list. You know on the root bridge, it's always gonna be forwarding out of all of its ports because it's in charge of the entire segment, the entire triangle. Let's keep it simple. Okay? The other non-root bridges, now you have to delegate, okay, where we're forwarding at, where we're blocking at. You pick who has the fastest link, perfect, designated. Between the 2 switches that are not the root, switch 10 and switch 5, we block it. Boom, simple as that. And you treat that for every triangle or every segment, as they say in the real world. Treat that for each one, dude, you could troubleshoot a whole bunch of issues, big topology, because the essence of everything, right? And the essence for spanning tree is that it's helping you create one path from the source to the destination. I'm gonna say that again. Spanning tree is just helping you create one path from the source to the destination. Our source being PC11.
Create.
Okay.
Path.
We have 2 ways to get to the DHCP server.
Source.
Right?
You
got 2 ways.
Destination.
Different color. Got two ways. Right? Just looking at it, fellas, right?
Mm-hmm.
Yeah.
Are we gonna use just between this triangle? Are we gonna use the link going towards switch 10 or the link going towards switch 5? Based on what you just learned tonight.
I'm gonna say switch 10, but I hope I ain't wrong. Wait, let me relook at the numbers.
Keep going. Keep going.
Oh,
Keep going. You're good. Keep going. But
okay.
I need you to tell me. I need you to tell me why. Why did you choose switch 10?
I chose.
Hold on, Twan. Twan, give me a second.
Right.
Zamir, because he's on to something. Zamir, why did you choose switch 10?
I chose switch 10 because that's gonna be the shortest route for one, and for B, that 1,000 MPs. I realized I was looking at it backwards earlier. I know the higher the numbers get, the lower the cost. So that's also
Zamir,
a low cost.
Slow it down.
Oh.
Slow it down. You're on the right path. How do we determine cost?
By the speed.
Okay. Okay, let me let Hakeem in. Who has a lower cost based on their speed?
The path with
switch
switch 10. Because if you have to take the path to switch 5, you're going to be going 100, whereas the switch 10, you'll be going 1,000. They would be so.
Exactly.
Yes.
That's it. Keep it simple. Don't add shit else. That's it.
Okay.
So
yeah.
As soon as I come back, he said, "Don't add shit else."
It's recorded. But guys, that's it. Okay. You know your cost. You know your election process. Just like Claude has it, and I promise y'all, copy what Claude just posted in the chat. Keep it simple. Once you know your cost, you know that's your process. That's it. Don't let these topologies you see on the screen right now or on LinkedIn or whenever you start working a networking job to intimidate you.
Yeah.
I just watched you guys converge a redundant topology. Easy.
Oh, wait. So it would be the link coming from switch 5 to switch 10 to switch. What's that? Damn.
Yeah, my bad for cutting you off, Twan. What was your question earlier, Twan?
Oh, nah, I wanted to just kind of I know you're talking as a mid, but I wanted I couldn't see what was the example that you was giving.
Yeah, so I was asking him, right? If we're looking at PC11, okay? Let's say PC11 wants to communicate with the DHCP server, okay?
Yeah.
What link is switch 9 going to take to reach the DHCP server? Is it going to take the one towards switch 10 or switch 5?
Oh, I see what you're saying. It's gonna take the link going towards switch 10 because switch 10. The link towards switch 10 because the link going towards switch 10 has a lower cost.
Okay, perfect. So I'm gonna throw you a doozy now. Okay, yeah. So now the packet's at switch 10. Between which way is switch 10 gonna choose to get to the DHCP server? Is it gonna go through switch 5 or switch 7, and why?
Switch 5 or switch 7? Switch 5 to get to the DHCP server?
To get to the DHCP server.
That's a trick question.
Hold on. Give me 1 second. Give me 1 second.
You guys just learned it. You just learned it.
Give me one moment. Give me 1 moment here.
I can help
Zamir, help him out. Zamir, help him out. What is the speed?
Two things that I'm noticing. First off is that going down from switch 10 to switch 5 is blocked. That port is blocked, so I don't know if it's gonna receive.
Nope.
Oh.
Hold on, Zamir. Hold on. A whole different triangle. Okay. Whole different triangle between.
So we're not going by that no more. So it's just the 1,000.
That's a whole different. That's a whole different.
Yeah.
That's a whole different segment.
Okay.
Whole different triangle. Okay.
Okay.
So the triangle I'm talking about now.
I still have.
You got it.
Yeah, it's because it's
Okay, go
still
ahead.
high. It's still higher to go that way. The cost is higher because we know that 10, the cost is higher for 10. It's a lower number, and then you have to still go through 100, which is higher. When they could just go through switch from switch 10 to switch 7 at the 1,000, and it's gonna be a lower cost. And then that switch will recognize the server because it's on that switch. Well,
Okay, let's
it's
clean.
forwarding over there.
No,
It
you're
just
good. You're good. Let's clean. Hold on, Zamir. I'm still with you. So let's clean it up a little bit. What's the cost? Let's compare. What is the cost? Rather than
Okay, so
going
I had to
switch
pull my
7 rather than
numbers
switch
up.
5.
Okay.
Go ahead. Go ahead. You're an engineer. Go ahead. Pull your numbers out.
Yeah, let me just
Do what you gotta do.
STP cost.
Guys, please don't ever feel like you gotta remember all this in your head. In time, it'll
Okay.
come. Pull up
So-
Google. Pull up your notes. Do what you gotta do.
So 100 and so 10, 19 to 119. Okay, so I got it now. Let me see. So
Okay.
when I'm looking for the cost, it was big. Hold on, I just had it up. 1,000 is 4, so it's gonna cost 8. The cost is gonna be 8, if I'm not mistaken.
Okay.
To go through switch 10, but if you go the other way, that 10 is gonna be 100, and the other one is 19. So my bad, I'm looking. It's gonna be 19. I'm going back and forth. So 119. So the cost would be higher to go the other way. If I'm not mistaken, the
Good
10, yeah, and then So yeah, I'm sorry, going back and forth
what if
because the 10 is worth 100 and the 100 is worth 19. So that's 119 together, whereas 1,000 is worth 4, and that's gonna be 8 versus 119.
Good shit. Now, Zamir, stay with me. I'm gonna throw you a
Okay.
doozy.
That's my boy.
What if I do this? These match. Which way is switch 10 gonna take to forward that packet?
So when all those match, give me and let me be resourceful for about
Take your
30
time.
seconds.
Take your time. Do what you got to do. Remember, you guys are the engineers. Take your time. Do what you got to do. Come with me with an answer whenever you're ready.
Let me look this up because I don't want to be
Go ahead.
assume.
It's in that link that I just sent y'all.
Yeah, because this is gonna go to a tiebreaker.
It's all good. This is good. Y'all are doing excellent. Y'all are doing excellent. Keep going. Keep going.
Yeah, so long as audible. My fault.
Oh, wait a minute. I'm thinking I might
Okay.
know. I read a little clip, but now I'm thinking, so have we decided though when we redid this triangle about which one is the root bridge? Well, no, we could decide that by right now by looking at which one is the lowest out of these 3. Was going for PC11, so the root bridge would be there.
Zamir, you're the engineer. Converge topology for me. Go ahead.
I'm gonna say going that way that it may take switch 5, the other path than I said the first time, only because they both match, and I'm thinking that out of these 3, switch 5 would be the root bridge because it has the lower max, so it always goes closest route to the root bridge, if I'm not mistaken.
Okay. For this triangle. So keep going. So switch 5 is the root bridge. Okay. Keep going. Convergent. You on the right path. Keep going.
Okay, so you asked me which way to go from PC11 to, you want me to, what you mean converge? Do everything, like the root ports, you saying that?
Everything. Everything. Go ahead.
They ain't ready. Okay. Let me go get it. Okay.
I know you can do it. I know you can do it. Go ahead.
Okay. So let me get focused. Okay. So this is the root bridge. So just give me 1 second. Let me look at it really good.
Okay.
Shout out to David for the method behind the madness.
It's a fake.
Root port. This is the root bridge. So here we go. What I did. So I'm thinking that, and it's the lowest cost, but they both got 1,000. But it's that triangle. So I know that G 1/2 with the green line with the 1,000 coming from switch 5, that's gonna be a designated port. That G12 interface.
Give me 1 second. Let me
okay.
get my annotation tools together. All right. So Hold on. Which one is going to be a root port?
So, my wait, hold on, not root port, excuse me, designated port. That's what I'm starting.
Okay.
And with the designated port, I'm gonna start with the one right there that's blocked out, that say block. That's the G2. That's the designated port, and then the one next, and then the G12 with 1,000, with megabits, with the green is also a designated port.
Mm-hmm.
And then we know the other
and
end
why?
of the
Hold on. And why? Why is that?
Those are designated because that's the root bridge. So the designated ports are always coming from it. There's always forwarding, and that there aren't no block ports or anything. It's the root bridge. So it's always sending information.
Exactly. Keep fucking going. Keep converging.
Okay.
Let's go.
Okay. Switch.
Let's go.
Come on.
Keep fucking going.
Let's do it.
So I'm gonna have to give switch 10 at the other end, G2-1 as being the root port, because it's at the other end designated port. That's where it's receiving as this port that's closest to the root bridge. Same thing with switch 7 and
That's
G.
not enough. No.
Oh, okay.
Go back.
Okay.
What is the election process for a root port? I know you know this.
Sorry, I did say it wrong. Thank you for correcting me on that. It is the lowest cost to the root. Is the lowest cost to the root bridge, and with that being a 4, and from that port, that's going to be the root port.
Good. Okay. All right, let's keep going.
For switch 7, same thing as the root port is the G, I0/1 to switch 7, and same thing, lowest cost and 4. Now, once we set everything else up, then we have to block. So, wait, I'm gonna make sure I'm right though. Okay, hang on, overthinking. I'm thinking I'm blocking the last one. No, I have to choose one of these to block. Oh, let me remember. Okay, let me breathe.
You're the engineer. You're the engineer. Breathe. Take your time. Do what you got to do.
Okay. Which one you gonna block and why? Okay, give me 1 second. Let me refer real quick. Be real resourceful and remember exactly
Take your time.
And let me go see client notes again. Find a root, turn on one designated port segment, block everything else. Okay, so I'm thinking that, I gotta close this. I'm gonna block, trying to think about which one I'm gonna block. This is the root, this is the closure. Okay, I am a little stuck here, but I'm thinking for.
It's all good. It's all good. Look at my screen.
Oh, duh! Like, okay. Switch the lowest cost root.
We become the designated case for the tie. Lowest bid becomes a designated switch.
And Hakeem, can you help him out and tell him what is the bridge ID?
Bridge ID is the priority and the MAC address combination.
Okay, perfect. So what if the priority matched up? What would be the election?
You would go to the loop back address. Wait. Yeah, my bad. It will be
if priorities
the port priority.
You saying if they match things, then what do you go to next to decide?
Yeah, right. So if we look at that page I just sent you, hold on. If we're looking at the bridge ID, right? The bridge ID compiles of the priority number and the MAC address. We didn't designate any different VLANs. So the priority number is going to be the same on all these switches. Okay. Right. So if they're the same, the other part of the bridge ID is the MAC address. So that means the election process is going to go between the MAC addresses of both switches. Okay.
Yes.
So with that being said, go ahead and draw this up again.
Is it not? Is it not the VLAN number that is added or subtracted from the priority?
Oh,
No,
that's
the
when
VLAN number is added to the priority. The
Added
VLAN
to the
number is
priority.
added to that priority.
Right.
Mm-hmm.
But I think I know what he might be talking about, like when you get to the ports and you have to then decide by the port. But I forgot the rules for that. Let me see.
Well, that's the chassis.
Oh, it's
number.
the
That's-
lowest port. Is if I'm trying to think. I ain't reading them.
The lowest port number.
Yeah, take
the port
take your
priority
time.
is
Take your
the chassis number for the port.
I'm thinking
guys, look at that
GI
page.
0
that I
/
sent you.
0 interface is gonna be blocked.
Hold on, guys. We're selecting the designated port. Look at that page I sent you and take your time on answering this question.
Hold on.
I think we'll be blocking GI 0/3
Okay,
I
so why?
can't see
Why
anything.
then?
because switch 7 has a lower MAC address, and the MAC address is the tiebreaker. Because the priority is the same.
Exactly. So who are you blocking on?
Switch 10 0/3.
100%.
Hmm.
100%. Did you guys get that?
That was
Yep.
because 7. He said 7 had the lower MAC address. So I knew after that first time because they kept saying the numbers like 37 something for priority match. You go by MAC. So since that's the lowest one out of them two, that's gonna be the designated port, and the other one is blocked.
Yep.
Block everything
100%.
else. Wow.
100%.
Yeah. This has been amazing. I started off looking like I couldn't identify the root.
It's all good.
root bridge.
It's all good. It's all good. And I know the election process can be confusing. So it's gonna take practice, dog. It's gonna take practice. So that's why you write this out. Give a switch fake MAC addresses. Y'all write it out. Practice every day. Have it written out. The election process. After a certain point, y'all gonna be able to just, oh shit, all right, cool. I know who's gonna win the election process.
Yeah,
okay?
I'm ready for this. When we first started, I didn't know switch one was the root bridge. So to now be able to look at this one and still be able to pick root bridge, designated port, root port, yeah, I'll be studying. I'm happy.
I just parked y'all for some reason. I thought you said, what if everything matches? And I know this sounds stupid, but I'm thinking the MAC address match and the priority. I don't know what I was thinking.
Nope.
And that's not even
good.
possible. That's not even possible.
I didn't want to interrupt you. I started to say
not even possible.
My attention is a couple play. I can't do that. That's not even.
I was thinking. I saw that on the video that if they all match or all on the same V line, they like 37 some number. Then it's the MAC address. So I knew, but I already thought like we got the root bridge. I couldn't tell that now it goes between those two. So that tied that in for me.
So guys, look at this. And guys, put this in your notes. Take a screenshot, whatever, right? The election right here, and it explains what the bridge ID is, right? Just in case for somebody that doesn't know. The bridge ID consists of the following: the priority and the system ID, which is the MAC address. Okay? That priority is typically this number right here by default, whenever it switches out the box. It's the same. Plus, like Hakeem was saying, plus the VLAN number, right? Because you could have different VLANs on the switch. So if you don't change anything, right, and we just have VLAN 1, it'll be 327.68 plus 1, which would be 327.69, right? That'll be the priority. Then the difference maker, right, would be the MAC address on each switch. Okay? We'll have another session as far as what happens if we manipulate the priority, and then boom, we can go ahead and talk about that. But let's say everything's default in the priority section within the bridge ID. The other part of the bridge ID, which is the MAC address, that's the difference. That's the difference. Make sense?
It does now. I just done came all the way together. I didn't know what to do after that last one. So now I know how to make that final decision between the two of which one you're going to block out. What's the last designated port?
It's all good. Let's do one more. Let's do one more. The spotlight's still on you. And
you doing your thing,
you,
bro.
Hey, I just checked my phone. I was on 1%. I'm happy I checked it because I put the cord right in. So
go ahead and charge it. Go ahead and charge it. Yeah,
no.
Good?
I'm still gonna be on. I'm on the charger, so I'm good. We good.
All right, perfect. All right.
I hope you got a fast charger.
No, as long as it don't die, I'm
I
good.
want you to do. Yeah. I don't need it to die. So here's what I want you to do. PC 12. It's in the bottom right corner. Okay.
Okay, I see it.
I want you to tell me the path it's gonna take to get to PC 11.
PC 12 is going all the way to PC 11. Let me see. Okay, just give me a second. Won't be too long.
Take your time.
Oh, so it's gonna definitely be going from switch 2 to switch 5. Oh, are we only using those 3 or? Okay.
Think about it now.
Okay, so I'm still gonna go with going switch 5 because that's a lower cost, and then going from switch 5 to switch 10 is also a lower cost, and then from switch 10 to switch what's this 9 is also the lower cost, which is the same. They all 4, so at that point the cost is 12 to get the PC 11.
Okay, mark it for me again. Let me
Okay. Them colors don't mean anything, right? You're not saying that it's a different network and nothing like that. The colors don't mean nothing, right? You just want the path.
Nope. Remember what I said. These are the redundant links. Okay?
Oh, okay.
So that's the triangle or quote unquote segment between the entire, between the 3 switches, or
okay.
in this case 1, 2, 3,
well,
4. Okay, so just try to help you out. I want you to look at it as per triangle. Okay.
Okay.
So what path is it going to take? So I'm here. Where am I going to go?
You made me nervous, but I'm still gonna go with switch 5 because that's a lower cost to go to switch 5 is 4 versus the 10, which is like 100 or something, or 19. Have to look it up.
Okay. Now from switch 5, where am I going?
From switch 5, I would say up to switch 10 because that is a lower cost than going because the 1,000 is 4 and the 100 I gotta look up again, but the value is definitely higher. Let me look it up and tell you exactly what it is. And for 100, the value is 19. So at that point, it'd be 19 plus 4, which would be 23. But the other path is a lower cost than that. So already we're at 8. And then from switch 10, I would go to switch 9.
Okay.
And that's the same thing, another cost of 4. And at that point, we made it the PC 11 and only with a cost of 12 versus going the other way, which even if I took that 1, 4 and plus that, like I said, would have been 23. It's the next, lower cost route.
Claude, any words?
I think they're good. I think they're good. It's clicking. Yeah.
It's clicking. I think it's clicking. I think they're ready for Bowser's Castle.
If they can, if they can get like Neo and see the triangle in the Matrix and just focus on that, I think they'll be fine.
Okay.
Oh, Neo, not new Neo.
I think they'll be fine.
So guys, big thing that Claude just said, right? And Zamir, I marked it for you on purpose. Think of it as a triangle, okay? Redundant links, okay? You break down the network between each other, okay? And we'll have this same breakdown within the CLI. So we'll do it probably some other day. We'll go ahead and have a part 2 of this. But you break it down per triangle, okay? If you do that, you make things simpler for yourself, okay? And so, just like you just did, you broke down, you said, okay, perfect. Cost of, this has a speed of 10, speed of 1,000. Speed of 1,000 has a lower cost, as we know, despite if we know the actual number or not. So I'm going to go this way. I'm going to go that way because, versus, the speed of 100, speed of 1,000, speed of 1,000, we're going to go here. So you convert it, right? You think of it as a triangle every time. You do that, you're golden. You're golden.
I actually like
I think they're good.
now. Claude, send another question tomorrow.
All right.
So they poking the bear, huh?
Listen, Claude,
I don't agree with that notion. I don't know what they talk about.
I'm ready for this.
All right.
But yeah, that was good. That was good.
Ready from Grace S23.
Yeah, good stuff, fellas. So, yeah, great stuff. We're gonna have a part 2 to this spanning tree session because again, I want you guys to understand it. And again, my reason being, I want you guys to understand layer 2 because whenever we get to routing, we get to layer 3, we get to that section. They have their own calculation that's similar to spanning tree. Okay, so just like, and Claude will tell you, you have to know something simple like spanning tree before we get to something like Claude, help me, OSPF or eGrip, EIGRP. You have to. This is the foundation.
Matter of fact, Twan was speaking on it earlier in the chat.
Oh yeah, Twan said it perfectly. It's
Twan
like
made
OSPF,
a reference,
but for layer 2.
Yep.
Perfect.
Yep.
Simple.
In my confusion, I'm saying that what's next? The lowest loopback address.
And that's that brain. That's that brain getting rushed. That's all that is. Yeah.
Yeah, that's all it is. So remember, guys, key thing, and I hope y'all take a page out of Zamir's book. Slow it down. Just like he did. He said, yo, give me a second to research. Y'all are engineers. We're waiting on you. Y'all are engineers.
I like that. We waiting on you.
That's nice.
All right. On me.
How the hell the issue is going to be resolved if y'all being rushed?
Right.
Notice the value. Notice the value.
Y'all the doctors, y'all the scientists, y'all whatever. Y'all got to do it. Y'all got to fix it. Nobody else can fix it. Y'all gonna do the best y'all can, but take your time. Don't rush.
Yeah, they're gonna rush you at McDonald's, but they ain't gonna rush a doctor to do the surgery. They're gonna wait and hope everything goes well.
Exactly. Right. But even with McDonald's, right? You don't want your food rushed. You might be missing, the mac sauce or what have you.
Or some extra mac sauce. I ain't gonna rush them.
Exactly. So it's, Zamir, I love how you did that. Every time you had to look up something, you say, yo, all right, cool. I'm going to go ahead and give you an answer in a moment. Give me 1 moment to go ahead and research. Guys, perfect answer.
Yeah.
Perfect answer. What I'm going to do, I'm going to just shut up and just let the engineer do what he got to do. Because my issue won't be resolved until he does it.
Yeah. It's like what you said the other day, don't let them rush you and your anxiety. You know what you know, or you know where the resources at. Hey, they on your time.
Exactly.
Yo, that gets me every time. Sporadic thinking, it just starts spewing out whatever.
Slow it down.
No, don't let them put that pressure on you. I done had jobs where they do that to you. Sometimes even now I work remote on the phone. So I have to tell them, okay, just give me a minute. Let me research the issue because we're going to get it done, but let me make sure, it's sufficient. And let's see how long.
So welcome to the world of customer service.
Guys, what y'all talking about? Goldman, what's his name? Jack Goldman. He actually talked about that, he's the grandfather of emotional intelligence.
Oh, yeah.
And what he's talking about when other folks start getting in your ear and then you start going out in left field, it's called emotional hijacking.
Yep.
Daniel Goldman, that's his name, Daniel Goldman.
when you scientifically, when somebody tells you something, your brain wants to do it real fast.
Yeah.
Before you actually don't do it. Some people are conscious of this and some people aren't.
Mm-hmm.
And I had this same conversation with Dave today. We were talking about the session last night. I was picking up my little girl from school, and I was saying, I was like, you can hear in those guys' voices that their gears was running 100 miles an hour, and they're trying to formulate. You know, they know they want to do this, they know they want to do that, but they're trying to formulate how to do it. At that moment, because I think Hakeem would, and I don't mean, I'm not trying to pick on anybody, but Hakeem, you were actually going through that emotional hijacking. So it was like,
oh yeah, absolutely.
You know what you want to do, but now it's like, it's almost like your fingers are stumbling as far as what do I do? You know. So that's exactly
that
what
reminds me of
happens.
like when I first started working. I worked at GE, so I would bring appliances and install them and stuff. When I first started working, people would ask me this, and I would try to do this and do that and waste my time, even though it don't work.
Yeah.
But as I was in my profession, a year later, I'm looking at it like I'm not doing that. I'm gonna save a whole bunch of time because I already know.
Yeah. And you gotta remember too, they calling you there because you know. So if they knew and they think it's this and that, then y'all probably should have tried this and that already.
So, exactly. If they knew, they wouldn't need you, right?
Right. So
And
let me see
that's
what
the main
we
thing
about
when
to
it
do.
comes
Give me a second.
when it comes to customer
Exactly.
service. That's a big thing, especially when it, like, say for instance, for me, that's all I've known is customer service. So when you start, you get those customers that call in and think they know everything and want to. Well, if you knew all this before you called in, you should have took care of it before you called in, kind of, right?
Right.
So
That would be the
me,
logic.
and
Yeah.
look, I give it to them. Like, I mean, look, and I used to kind of get in trouble for it. They was just like, well, why do you talk to them like that? Or why do you, I mean, because this is the thing. If y'all sit here and let these customers call in and talk to us like this, y'all got stuff that y'all want us to go by. Y'all want us to come in and get them off the phone in 10, 12 minutes. Okay, cool. So let's get to the bottom of it. Let's ask the questions. The questions, if you don't want me to ask these questions, I'm trying to help you. If you don't want me to ask these questions, fine, I won't ask them. So what would you like me to help you with going forward? Because at this point, you don't want my help with what you called in for. So it's a matter of asking, okay, well, hey, I do understand you're frustrated. I do want to get you taken care of. This is your goal is the same goal that I have, is to basically make sure we get you taken care of so we can get this up and running. And a lot of times if you stand firm with the customer first or whoever it is in the beginning, and instead of letting them walk over you, it tends to end up going a lot better. They tend to respect you in the end because they're so used to calling into these different places and saying anything they want to say or doing things how they want to do. And they wonder why they don't get anything done.
Can I add something to that too? I want to say, like he said, you want to also, and even with my job now, do that. You want to also make sure you asking the correct probing question to get to the bottom, because when somebody non-technical think is going on versus what you know might be going on, it's two different things. So I have people tell me problems all day, and I have to say, well, wait, what are you trying to do? Because that problem could be caused by something totally different.
It could even be the same what you're calling in about.
Yeah, and you want to show them that you also in control so that they trust you, so they're not running in panic and saying, oh, well, do this and do that. And you know, this is what we're going to do today. I'm going to go through these steps. And, you know, I had a job even when I did, you know, I was a claim adjuster, and the people called me, I'm on the side of the road. I've been in an accident. Okay, yeah, I let it fit for 2 minutes. After the 2 minutes, hey, we're going to get this handled for you, but I need to get like that.
So one of the things that I've been taught, like in customer service, is to move them forward. Like if they continue to be those type of people who.
Hey, Brian, give me a second.
Hold
on. So no. So don't mean to cut you guys off. We're gonna go ahead and just we're gonna go ahead and close it because we're just gonna keep the recording just based on Spanning Tree.
Okay.
All good words tonight. Again, sorry to cut you off, Brian, but all good words tonight. All great advice. I think we can sum it up as to, you know, I think I'm gonna quote Claude's Matrix line, right? And the famous line that Morpheus said, you know, right? The famous line that Morpheus said, and I want you guys to think about this and tell you guys, you know, affirm it every morning and every night. don't think you are. Know you are. Okay.
Yeah.
All right.
I guess you might be a little right.
Absolutely.
All right. And on that note, fellas, I'll go ahead and end the meeting. You guys have a great night.
All right.
Great night, man.
Awesome, man. Awesome. Thanks,
Great
everybody.
job, everybody, man.